Right, grade 8, our next lesson is on mixing the laws of exponents. So can you do all of the laws together? So let's just quickly revise what the laws said. The first law said that if you multiply powers of the same base, so that means if you have something like x squared and you multiply by x cubed, because remember the base is the x's. Now it says you must add exponents. So this would be x to the power of 2 plus 3, which is 5. So that's our first law. Our second law says if you divide powers of the same base, you subtract exponents. So that would be something like x to the power of 5 divided by x to the power of 3, which would be x to the power of 5 take away 3 is 2. Now personally, I don't like the way that law is written, so I always say to myself, if there's 5 x's at the top and 3 at the bottom, how many can land up cancelling? And then 3 could cancel, which would leave me with 2, and then I always say to myself, where are those 2 x's? They'll be left at the top because there were more at the top to start with. So that's how I prefer to think about it. Okay, then law 3 is when you raise a power to another power. So that's called raising a power to another power, and it says you multiply exponents. So this is when you multiply exponents, not when you're multiplying powers of the same base, when you're raising a power to another power. And the last law says that you can distribute an exponent to all the factors in a bracket as long as there's only one term in the bracket. So that what that means is if you have x and a y and it's squared, you can distribute that square to both of those factors only because there's one term in the bracket. If there were 2 terms, so if this was x plus y, then that's a whole different story, and we learned that in grade 9. Okay, let's do a whole bunch of examples together and write some notes as we go on how we should approach questions like this. Okay, now my first question says x, and then it's got a bracket, x squared all cubed. Now my first hint and tip is I always get rid of the brackets first. So I always do my raising a power to another power first. So always get rid of brackets first. So the most important thing in exponents is not to rush, but to do one concept at a time. So here, I would first attack this concept. I would completely leave that x that's just there all by itself, just leave it alone, and do my raising a power to another power. And when you raise a power to another power, you multiply. So that's 2 times 3, which is 6. And now, I can do when I multiply powers the same base, I add exponents. Don't forget there's an invisible 1. So this is x to the power of 7. So if I just write myself a little note here, going from there to there, that was law 3. And then going from there to there was law 1. So I generally try to do my law 3's first. If I see a bracket, I immediately deal with the bracket, and I ignore other things until later. Okay, let's look at the next one. Now once again, there's a bracket. Always deal with your bracket first. So in this case, I'm going to leave the 3p squared. I'll deal with it later. And actually, there's 2 laws going on here, because you've got distribution and you've got raising a power to another power. So you've got law 4 and you've got law 3 here. So law 4 says that I can distribute this exponent. So this is going to be 2 raised to the power of 2, which is 2 squared, which is 4. And it's p also distributed, so it's p squared. Now I don't actually have really any exponents here to raise a power to another power. So in the next question, what I've done is I've made sure that there's an exponent inside the bracket as well, so that we can practice this law 3. Whereas in this particular question, I didn't really have much law 3 to worry about. So once I've gotten rid of my brackets, I simply use my law 1. And my law 1 says when I multiply powers the same base, I add exponents. Now just be careful, there's multiple things to multiply here. So don't forget that when we multiply, it's signs, numbers, variables. Now there's no signs to multiply, but there's 3 times 4, which is 12. And then my variables, when I multiply powers the same base, I add my exponents. So far our kind of steps are always get rid of your bracket first, and then just do your basic multiplication. Okay, what's our next question? Now this one is going to involve law 3 and 4. I thought the previous one did, but this one definitely does. Because what I'm going to need to do is I'm going to say, oh, this is 2 cubed and it's y squared cubed. So I'm going to ignore this negative 3y for now. Notice you can't put that negative 3y into the bracket before you deal with the exponent. So let me just actually write that. That's very important. You can't multiply negative 3y into the bracket first. Now this is because that exponent only belongs to the bracket. If you put that negative 3y into the bracket first, you're saying that that exponent belongs to everything. So this is because the exponent only belongs to that bracket. So if I put it in first, I'm then giving an exponent to everything, and that's not true. So I leave the negative 3y, and all I'm going to do in my first step is law 3 and law 4. So 2 cubed, remember it's not 2 times 3, it's 2 cubed, which is 8, 2 times 2 times 2. And then when you raise a power to another power, you multiply those exponents. So y to the power of 6. So just be careful, because you're not multiplying the numbers, you're cubing 2. But when you raise a power to another power, your exponents multiply. Now the reason for that is there technically is an invisible little 1 there. So you are using law 3. You're saying when I raise a power to another power, I multiply. So it's 1 times 3, which is 3. So it's 2 to the power of 3. So just be a little bit careful. Okay, now I'm multiplying signs, numbers, variables. A negative times a positive is a negative. 3 times 8 is 24. And I have 1y and another 6. So I have y multiplied by itself 7 times. Right, on to the next one. This one's a little bit more interesting because there's a fraction, but it's actually really not that bad. Now this one is going to be simplify the top, which involves a bracket, so that's distribution. So that's a squared, b squared, and you leave the bottom. So always simplify your top and bottom first. Oh, that doesn't say simplify, so let's try again. Simplify your top first. Once you've simplified your top, you can now just do some division. And if I have a look at this, I have a squared at the top and a squared at the bottom. So how many a's will be left over? None of them. So they're all disappeared. And I have 2 b's at the top and 1 at the bottom. So 1 will be left over at the top. So I don't actually like to subtract my exponents because often it confuses me if there's more at the bottom. So that's how I prefer to think about it. Okay, now we start to get the more interesting questions. My first step here is wherever there is a bracket, deal with the bracket first. So that was always my first step. Deal with the bracket first. So leave everything else alone. Leave the b cubed. Leave the 4b to the power of 4 and simply deal with that bracket. Now what's happening in the bracket? I'm distributing my exponent of 4. So when you raise a power to another power, you multiply. So this is b to the power of 8. And just be careful, that's not 2 times 4, it's 2 to the power of 4, which is 2 times 2 times 2 times 2, which is 16. Okay, now my next step is always simplify your top and bottom first. So simplify my top and bottom. Don't forget that exponents are easy as long as you go step by step. So if I look at the top, I'm multiplying. There's no real signs to worry about, and there's only one number, that's 16, but I have 3 b's and then another 8, so I have b to the power of 11. And fortunately the bottom is simplified, so it's not too complicated. Okay, now when I'm dividing, I simply do signs, numbers, variables. So there's no signs to worry about, but 16 divided by 4 is 4. If there's 11 b's at the top and 4 at the bottom, 4 can cancel, which will leave me with 7 at the top, because that's where I had more to start with. So what seems like a little bit more of an interesting question, because there's brackets and there's a fraction, actually lands up being not too bad at all. You just got to go step by step. Okay, now f is also very, very similar, because if I look at f, I've got to first do my bracket. So if I do my bracket, I distribute my power of 3, and when I raise a power to another power, I multiply, so 2 times 3, and b also gets the exponent. So I've done my bracket, and then I'm going to simplify the top and the bottom. Now if I look at the bottom, I'm sure we'll agree that it's not simplified. So there's nothing wrong with in the same line. Now that I've made the top look a little bit more simple, let me make the bottom look a little bit more simple. So I have a squared times a, which is a cubed, and b times b to the power of 5 is b to the power of 6. And now I can simplify the top and the bottom together. I can do my division. Now if I have 6 a's at the top and 3 at the bottom, I'll have 3 left over at the top. But if I have 3 b's at the top and 6 at the bottom, I will have b's left over, and there'll be 3 of them, but they'll be at the bottom because that's where more started. Right, so again, that looked a little bit threatening, and it landed up being quite easy. Okay, let's look at G. There's a lot going on in G, and this is probably the worst a question could get. So my first step is deal with the brackets. Now there's 2 brackets here, so I'm going to deal with both of them. So I'm going to distribute my 2, so that's 3 squared, which is 3 times 3, which is 9, x squared, y squared. So that's my distribution. Okay, now there's still a times x to the power of 5, which I'll have to sort out just now. And there's an x, y, and it's times, and I've got another bracket. So I'm going to distribute my exponent of 2, and when you raise the power to another power, you multiply. So that's 2 times 2, that's 4, y squared. So first your bracket. Then I'm going to spend my next line simplifying my top. I never bother cross-cancelling until it's simplified on top, because otherwise it gets too messy and I can't see what's going on. So signs, numbers, variables, there's no signs and no real numbers to make this interesting, but there's 7 x's on the top and 2 y's. And at the same time, I'm going to simplify the bottom. So at the bottom there's no signs and no numbers to really worry about, but there's x times x to the power of 4. So when I multiply powers the same base, I add the exponents, y cubed. And now all you need to do to finish this off is to do your division. So you simplify your top and your bottom together. Now again, there's no real signs, numbers is just 9. Now my same bases, if there's 7 x's at the top and 5 at the bottom, 2 will be left over at the top. And lastly, if there's 2 y's at the top and 3 at the bottom, 1 will be left over, but it will be at the bottom. Now this question would be worth quite a few marks, because you've got to do the bracket and the bracket, simplify the top, simplify the bottom, and simplify overall. So you're looking at a 5-mark question. So don't let a question for a lot of marks or that looks quite chunky scare you off. You've just got to do a little bit by little bit. Right, our last question for our last example for this section is looking at what happens if you have a fraction which is all in a bracket and it's being squared. So first of all, who does this 2 belong to? The 2 belongs to everything in the bracket. So if you're going to go do distribution, you're going to be doing a lot of distribution. So the question is it worth doing distribution first? Because I've always said, do your distribution first. Is it worth going distribute, 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 distribute? It'll work, but is there a simpler way? Now, because the thing inside the bracket isn't simplified yet, if I want to make my life easier, I would simplify what's in the bracket if I can, because then I need to do less distribution. So I'm going to simplify inside the bracket. Sometimes you can't simplify in the bracket, and then you just got to go straight to distribution. So to make my life easier, let's have a look. Signs, I've got a negative divided by positive, that's negative. Now let me just be a little bit careful here, because you've got 3 over 6. Now most people would say 3 over 6 is 2, but just be careful, 6 is at the bottom. So technically you're saying 3 goes into itself once, 3 goes into 6 twice. So I actually end up with a 1 and a 2. Now let me raise my working there so I can see. How many x's do I have left over? Well, I have 2 at the top and 2 at the bottom. So I have none left over. They will cancel each other out. And my y's, I have 4 at the top and 2 at the bottom, so 2 land up at the top. Now my distribution is much, much easier, because what's inside the bracket is just so much better. So now that I'm going to distribute, don't forget everything in the bracket gets to the power of 2. So we discussed this a lot. Be careful, that's -1 squared in a bracket. When I raise a power to another power, I multiply, and 2 gets squared as well. So just don't forget that bracket, because -1 in a bracket squared actually becomes +1, and 2 squared is 4. Now that 1 over there isn't actually necessary, so you can leave it out if you want to. So don't forget that actually simplifying inside a bracket can help you if it's a complicated question which is all raised to the same exponent. Okay, so what you're going to do now is, inside your mini little textbook is exercise 8. And go and try exercise 8, and when you're done, you can watch the video on the memo for exercise 8 and see how you did. Okay, good luck.